Okay. So today we are going to talk about air pollution. So today we only have 4 main points. So first, I would like to briefly talk about what is atmosphere and what are its main properties, because the air pollutants, they are transporting in the atmosphere. And then we are going to talk about the significance and some of the brief history about the air pollution. Then we are going to talk about the regulatory standard of some of the air pollutants. And finally, we will talk about some of the air pollutants one by one, so we can have some general impressions about these air pollutants. We still have... Okay, anyway. So first, I would like to talk about atmosphere. So for the atmosphere, I'm not going to read them one by one, but we should know the main composition of the atmosphere, and it also has some properties. But here I would like to talk about the temperature profile of the atmosphere. From the picture on the left side, we can see that, so actually we are living in the troposphere. And from this picture, we can see that the temperature is decreasing with increasing altitude within here. And after that, we have this stratosphere. And here we have something in between. We can consider it as a transitional phase between these two layers. From this picture, we can see that we know that when we are boiling the water, it will be something like this. And if we add the heat at the bottom, we know that this water will be very hot. And because the hot water or the hot liquid has lower density, so they will go up. On the other hand, the top water, they are relatively cold and they have larger density, so that they will go down. So in this case, if we have the temperature gradient like this, then we will have some convection in this water. And this is the same for the atmosphere. Because we have this temperature gradient, it is very hot, or it's warm at the bottom, and it is cold at the top. So in the atmosphere, we have the vertical movement of the air. And because of the vertical movement, the air pollutants in the atmosphere, they can just move with the winds or with the air. On the other hand, we can see this is cold and this is hot. The hot air will go up and the cold air will go down. So this is very stable. So the air pollutant is not happy to move vertically in this layer. So when we are talking about air pollutants, the air pollutants are usually in this region. And so for this one, do you guys have any questions? No? And because of the vertical movement of the atmosphere, we know that the temperature gradient is from hot to cold with increasing height. But in reality, because of the day-night change and because of the physical environment, the temperature gradient may not be the same as what it's supposed to be. We can see that the dashed line refers to the usual temperature gradient, and the solid line refers to the actual temperature gradient. We can see that under different temperature profile, in reality, we can have different plumes because the pollutants just go with the plume. And interestingly, we can see some of this. I think in the campus, I think we have some the heat from the ground maybe, and it will have the vapors. So every time when I pass through this, I will just take a look to see what it looks like. And then we can estimate the temperature gradient for now. Okay, anyway, so we may also have something like this. So in this case, we can see the temperature gradient change at a certain height. And in this case, we can have a boundary, because at this case, the cold air is at the bottom, like above here, and the hot air is at the top. So it is very stable. So the pollutant cannot get into this layer. And in reality, when we have something like this, and we call this inversion. So basically the air so we can have a shield here, so the air will not go through this shield. So they just go to here. So it tells us that if we are having some barbecue at our yard, it may have a negative effect to our neighbor. And this is usually happen in the evening, in the winter, because in the winter, like the ground is still hot, but when the temperature goes down, then the temperature will go down for the upper air. But for the lower air, they are heated by the ground, so we will have this shape. So sometime in the evening, I think for now, we may observe some of this plume. So for this one, do you guys have any questions? No? Yes.
So what happens is it gets like sandwiched between two types of air that are hotter than it or cooler than it?
Oh, you mean?
I guess like back to your drawing.
Like this one?
Yeah, so like it gets trapped under that line because the air above it is colder or warmer. Yes,
like so because the temperature is so in this case we can see that it follows this one. So in this region, the lower air will goes up and the upper air will go down. So it has a good mixing. But for here, the cold air is at the bottom. So the cold air just stays here. And in here, the hot air just stays at the top. So at these two regions, they are stable.
Okay, so the cold air is on top and it's pushing it down, and the hot air is on the bottom and it's pushing it up.
Yes, kind of like that. And so we can have this very thin plume. Yes?
Why for the farming plume is it, if it's a straight line temperature, why is the plume also straight?
You mean this one?
Yes.
So in this case, the temperature is like this. So the lower air is cold and the upper air is hot. So the air is kind of stable. So there is very small vertical movement of the air. So in this case, the plume is very thin. Yeah. And actually, we can see we have something like this and something like, especially something like this. This is very bad because if we are living here, we are exposed to a very large concentration of the pollutant. And the next, what's the air pollution? So basically, air pollution refers to any visible or invisible particles or gas found in the air that is not part of the original composition. So basically, air pollutant is the addition of the gases, chemicals, and particle matters into the atmosphere. And for now, the air pollutant primarily comes from the burning of fossil fuels, such as natural gas, petroleum, and coal. So basically, the air pollutant refers to the addition of the component to the atmosphere. And in history, we have many of the events related to air pollutant. But I think as an environmental engineering student, I think this would be the most famous one, like the smoke in London in 1952. And it has like 8,000 people was infected. But actually, when I look at this map, I find this one, like in India, it has more people that was affected by the air pollution event. So this is very bad. And because of the adverse health effects of the air pollution, it was regulated, and I will talk about it later. So first, let's look at some of the sources of air pollutants. So we know that the air pollutants may come from the vehicles, but I think for nowadays, we didn't see something like that. But I think for some of the big trucks, we can see the smoke. And also, this is a British national flag, but I don't think this is in Britain. I'm not sure what the language this is. Do you guys know?
Is it Indonesia?
Oh, I see. Yeah. But why it has a British national flag? I'm not sure. Okay. And the aeroplanes. Okay. Yeah, and the aeroplane, they can also emit the air pollutants, and they just stay in the atmosphere. So basically, the industry, and including the factory and power plants, they will burn large quantity of fuels, and they will emit air pollutants. And the burning coals and petroleum released like sulfur dioxide and nitrogen dioxide into the air. Also, the aeroplane, boats, and cars, they will also emit an air pollutant. And we also have some natural emissions. And in this picture, we can see that the volcano. And actually, the volcano is an emission source, the natural emission source for the air pollutants. And by the way, I like this game. If you guys play this, the Legend of Zelda: The Breath of the Wild. Yeah. Anyway, so except for the volcano, we also have the wildfires, like the wind blow dust, and volcano eruption. And also have the dust storm, especially in the arid regions. So they will add the particulate matter into the atmosphere. And because of the air pollution and air pollutants, it was availed by the human beings. And in the United States, we have the Clean Air Act. And we can see it was enacted in 1970, but it has different amendments. As far as I know, the latest amendment is in 1990, when I was young, when I was 0 years old. And so EPA required to investigate the environmental and human effects of air pollutants emitted by either stationary or mobile sources. And then we have the National Air Quality Standard. And here is a website. And we can see, so for the National Air Quality Standard table, it regulates different types of air pollutants. We can see we have the carbon monoxide, lead, which we have discussed. We also have nitrogen dioxide, like ozone, particulate matter, and sulfur dioxide. And I will go through them one by one. But we can see that we have the primary and secondary in the table. So what does it mean? So in this table, the primary standard refers to the standard to protect human health. On the other hand, we have the secondary standard, which is to prevent environmental and property damage. And from the table, we can see that some of them are not quite obvious, but we can see this PM 2.5. And for this 1 year standard, we can see that the secondary standard is kind of loose, is less strict than the primary standard, because humans are more important than the properties. And so in this table, it regulates different kinds of air pollutants including carbon monoxide, lead, nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. So let's just look at them one by one. But before that, I would like to ask you guys, have you guys ever seen this when you guys are young, or you guys know? So basically, this is a kind of like the coal. So in China, we call that beehive coal because it is kind of like the beehive. And in Japan, it was called the kneaded coal because it was pre-processed before use it. And from its shape, we can see that, so here is a stove. So basically, because it has a hole, so the air can easily go through this coal. Oh, so by the way, I think you guys didn't see that because when I searched the Wikipedia about this, it says that it was very popular in Asian countries. So maybe in the US it was not popular. And actually, when I was young, I usually see this like in the street restaurants where the place is not quite accessible to the gas. So people use this to cook. And in this case, we can say here's a stove. So the air can go in to here and then can go through the coal to make it burn. And in this case, we can see we have the carbon, which is in the coal, and it will react with oxygen to form carbon dioxide, and we have the heat. So we can use this to cook. But something will happen. We can see when the air goes to here, then most of the oxygen will be consumed. And as the air goes to here, the concentration of oxygen will decrease. So in this case, we know that if we have less oxygen, we have exceeded amount of carbon, the combustion will be incomplete. So it will have this carbon monoxide generated in this stove. And on the other hand, at the very top, when there is nearly no oxygen, like for some of the situation, we may have the carbon can reduce the carbon dioxide because the carbon has zero oxidizing state, and the carbon dioxide is +4 oxidizing state. So it can reduce the carbon here into carbon monoxide. So in other words, this stove may generate carbon monoxide in the air. So sometimes I may hear some news, like when I was young, some people use this stove inside the house in winter because they want to get warm. And because of carbon monoxide, it will be very dangerous. But now I think it is because of the more usable other energies, so this stuff just goes out from history. Okay, anyway, so let's look more at the carbon monoxide. As I mentioned, carbon monoxide is toxic, and at different dose or different time, we may have different adverse health effects. So in general, carbon monoxide is an odorless and colorless gas. So basically, when it is in the environment, we cannot identify it unless we have the symposium, like we have the adverse effect. So it is a little bit dangerous. And after being inhaled, the CO2, we know that we have the red blood cell that can carry oxygen, but the carbon monoxide can just replace the oxygen. So our blood cannot carry oxygen, which is bad. And the low concentration can cause some dizziness, headache, and some other adverse effects. And the high concentration can be fatal. So about the sources, the carbon monoxide is produced mainly by incomplete burning of carbon-based fuels, like the gasoline, oil, coal, wood, and some other things. It may also produce come from incomplete combustion of some natural and synthetic products, like the cigarette. So basically, cigarette is not good for our health. This is one of the reasons. And also, it can build up in high concentration in enclosed area, such as garage and poorly ventilated tunnels, and even along the roadside in heavy traffic. So I think it's good to know. Yes.
Is incomplete burning only if there is enough oxygen, or is it also due to temperature not being hot enough?
Oh, this is a good question. As far as I know, when it burns, like when it's burning, the temperature of the material is very high. So I think the temperature should be okay. But the amount of oxygen would be the limiting factor. Yes. The next one is nitrogen oxide. So for nitrogen oxide, I think it is very famous because it can form acid rains. So basically, we have nitrogen dioxide in the air. It can react with oxygen and water in the atmosphere. And finally, it can become nitric acid. And this nitric acid can dissolve in the rain to make it as an acid rain. As mentioned here, there's a major contribution to smog and acid rain. And I'm not going to read the adverse effects of acid rain, but we should also know that nitrogen dioxide will react with volatile organic compounds, VOC, to form smog. So the smog here refers to the air that has very strong oxidizing capability. So, for example, we have the nitrogen dioxide. It can react with VOC. I will talk about VOC later. And the oxygen with the sunlight. And then it will become, and so ozone and this OH radical. So this is not the OH minus. So this is not the hydroxide particle. So this is OH with with an extra electron here. So we know that the oxygen has very strong will to take electron from other atoms or molecules. So this is very oxidizing. And finally, it may form the ozone. And we also know that ozone is very oxidizing. So it can destroy the structure of many organic compounds. And in high dose, like the smog, so mainly refers to the air that contains these stuffs, can be harmful to human, causing some breathing difficulties, like some of these. And the main source of nitrogen dioxide are produced from the burning of fossil fuels, like including the gasoline and coal. Because in the gasoline and coal, although they mainly consist of carbon, but they have the sulfur and nitrogen. Yes. So when they are burning, so they can become SO2 and NOx. It is NOx here because we usually have NO2 and NO. For NO2, we know that the oxidizing state is +4, and for NO, the oxidizing state is +2. So we may have both of these. And again, here shows the effect of different NO2 at different concentration. I'm not going to read through this. But for this one, do you guys have any questions? No? Oh, by the way, when I was young, I think when we learn chemistry, we know this one. Have you guys heard about this? So it can make you smile, something like that. Yeah. So when I was young, I tried to make this, but I failed. I usually just get this and this.
How did you try to make it?
Because theoretically, we can just dissolve some metals, like let's just say iron, because iron plus the nitric acid, this is +5, and it can dissolve the iron. But as a reducing product, it can be NOx. So basically, if we control the amount of, like the ratio of iron and the nitric acid, we may get the product that has the oxidizing state is +1. But it is difficult. So I guess they may have some other method to do that.
Do that in lab next week.
What?
You can do that in lab.
Okay, anyway, we talk about the ozone, and let's talk more about ozone. And we know that ozone is very helpful or beneficial to human beings when it is staying in the top of the atmosphere. But when it is at the ground level, it is around us, it is bad. So when we are talking about the air pollution of ozone, we will emphasize that it is the ground level ozone. So it is not the ozone at the top of the atmosphere. So we can see that although ozone is very good to protect human beings from the ultraviolet from the sun, but if at the ground level, it is highly toxic. It can damage human health, the environment, crops, and a wide range of natural and artificial materials. So it has properties. I'm not going to read through them. And we can see the ozone can also damage the trees and plants and reduce the visibility. So about the sources, as I mentioned, I think in the last slide, ozone in the ground level ozone in the air comes from the reaction of nitrogen dioxide and VOCs plus the sunlight. So especially in the daytime, we have a bunch of sunlight, like for now. So we will have the ozone generated. But remember that we need to have some VOCs. And we know that the temperature is related to the chemical reaction rate. So this process usually happens in the summer. So in winter, it is relatively safe. And at night, the generated ozone can just oxidize the NO to form this one. So basically, the ground level ozone air pollution usually occurs in the daytime in summer. It is also a product of reactions between chemical reactions that produced by burning. But I think this relative amount is relatively small. As I mentioned, oxidization occurs readily during the hot weather, and the vehicles and the industries are major source of the ground level ozone. And so for this one, do you guys have any questions? No? Then let's look at the next one. The next one is sulfur dioxide. And again, we know that the sulfur dioxide comes from the sulfur in the coal, and it can form sulfur dioxide in the air. And in the atmosphere, sulfur dioxide is soluble, so it can dissolve in the water in the air, like the water drops. So it can form this sulfurous acid. And the sulfurous acid has so this is +4, or +4, not 5. The oxidizing state of sulfur is +4, and it can be further oxidized by oxygen to form the sulfuric acid. And this is a strong acid. When it is dissolved in the rain, the rain will be very acidic. and it can damage the plant. So basically, the sulfurous acid itself can damage the plant, and the sulfuric acid, it can also damage the plant. And also it is bad for the human beings. So it can cause like wheezing and shortness of breath, especially in those with asthma. But sulfur dioxide is better than carbon monoxide because it has a smell, so we can feel it. And the sources, it is produced when the coal and the fuel oils are burned, and it is usually present in the power plant exhaust. And on the right side, like it shows the adverse effect to some of the plants. And I think this is obvious. So I think this is interesting because we know that this is a pine tree. So for the pine tree, it is still green in winter. But if we see, when I was young, I see the pine tree become yellow. I saw the fall comes, but actually it doesn't make sense because it should always be green. So if we saw the pine tree become yellow, it means it was damaged. It doesn't mean the fall comes. So do you guys have questions about this one? No? And the next one is lead. And I think you guys working with lead for the whole semester. So it is a water pollutant, but it is also a air pollutant. And mainly when in the ancient time, when people driving the car, they put this one, tetraethyl lead. So basically we have a lead and we have the ethanol functional groups, like 4 connected to this lead. By having this lead in the gasoline, it can make the engine more powerful, so it can make the combustion more efficient. So it was very popular in the ancient time. But as the lead gets into the environment, released in the atmosphere, we find this is very toxic. And because it has the organic functional groups, so it can be easily accumulated in the humans and the wildlife. So it is banned. So it is bad, and it was banned in the world. And so nowadays, we can say the lead has been phased out of the gasoline. And however, the lead can still be inhaled or ingested from other sources. For the other sources, we can see that the sources of lead include like the paint. Especially when the paint gets old, it will just collapse, but it may generate some of the very small particles that can be floating in the air, which can be inhaled. And also like the smelters, manufacture of the lead battery, fishing lures, and some like the bullets, ceramic waves, and water pipes, which we have been working with, and some of the dye products. And so for this one, do you guys have any questions? No? And the next one is particulate matter, which is my research is working on that. So for the properties, so PM, we usually use PM to refers to the particulate matter. Particulate matter has different sizes and structures that are released into the atmosphere. I will talk about it later. And it can absorb water, heavy metals, organic pollutants, and microorganisms. So basically, if we have a particulate matter in the atmosphere, it can absorb like the water. It can also absorb the heavy metal and some of the organic pollutants. Also, the microorganisms can also live in here because it has so many of these. This can be considered as the nutrient for the microorganisms. So it is very happy to live here. So basically, the effects or the adverse effects of particulate matter, it may have two aspects. The first aspect is itself. The other aspect is the things that is absorbed in the surface of the particulate matter. But for this part, I'm going to use another slide, which I was presented in a conference, because I think it's more intuitive. And so this is the slide that I was using for the ACS meeting in the last year. My research is about, dispersion of the particulate matters. So in the next lecture, I will talk about dispersion. But for this lecture, we are talking about the air pollutant. So here I show the sources of particulate matter. And we can see the particulate matters can come from the road, especially the roads with no cement or with no plant. And it can also come from the factory, construction site, like mining and animal operation, like the chicken farm, something like that, and etc. For the size of particulate matter, we usually classified them into two. The first one is PM 2.5, which refers to the PM with an aerodynamic diameter less or equals to 2.5 micrometer. And PM10 also refers to the aerodynamic diameter less or equals to 10 micrometer. And here we have a concept which is aerodynamic diameter, because we know that here shows an example of PM 2.5 and PM 10. And I think for most of the example, the PM are just displayed as a circle or the sphere. But in reality, the particles can be something like this, and like the plate, and something like of the different shapes. So in this case, we can consider, for example, we have a perfect particle that has the diameter of 2.5 micrometer. And we can let this particle fly in the air. And similarly, we can use these particles of different shape. They do the same transportation or the dynamic things. So if these particles have the same behavior with this particle, with this certain size, then we can see that this particle has the aerodynamic diameter of 2.5 meter. So we use this to define like the particles with different shape. And because of the size of this particle, they can penetrate into human bodies at different extent. We can see that for PM10, it can just go to here. But start from PM 2.5, or for the smaller particles, they can get into the lungs of the human body, which is bad because the lung is just directly contact with the blood. So when the particles get into the lung, we know that we have different pollutants absorbed on the surface of the particle. So these pollutants will be released here, and then it may be transported by the blood to different parts of the body. So the smaller particles are more dangerous or more risky to human beings. And so here are some of the adverse health effects of the particulate matters. And we can see most of them are about the respiration system. And because of that, like we have go through all of the pollutants of the NAAQS. And from here, we can see that we have like the PM 2.5 and PM 10 concentration. And because PM 2.5, like the smaller particles, are more dangerous or risky to human beings, we can see that it has a higher regulation. Do you guys know why? So generally, PM10 includes PM2.5 because it refers to the size that is smaller than this. Yeah, so it doesn't mean the particle that has exactly the same size. So the regulation of PM10 is greater than PM2.5, even though PM2.5 is considered as more toxic. And then the next one is carbon dioxide, which is not included in the National Air Quality Standard, but it is also considered as an air pollutant because it has a greenhouse effect. So basically, when the sun hits the earth, the ground will just translate or transform the wavelengths, like the radiation from the sun, to a very large wavelength. And the CO2 can absorb this wavelength and transfer it into heat. That's why CO2 has a greenhouse effect. So with the increasing concentration of CO2 in the air, the atmosphere temperature will increase. On the other hand, as we learned in the water chemistry, when the CO2 dissolves in the water, it can form the carbonic acid. So the pH of the water will decrease. With the decreasing pH of the water, many of the animals living in the water system will in danger. So this is also bad. And so for CO2, do you guys have any questions? No? The next one is VOC. VOC refers to the volatile organic compound. And here shows some of the examples of VOC. We can see they are just, they are like small molecules. And as mentioned in the organic chemistry, when the particle is relatively small, the vapor pressure is large. So they are very happy to stay in the air. And so it itself has the adverse effect to the human beings. As shown here, like we have different effect to like different response to VOCs. And also we need to recall that the NOx plus VOC plus oxygen and plus the sunlight, it can produce ground level ozone. So VOC itself is bad, and it can help to generate the bad things also. So this is bad. And so for this one, do you guys have any questions? So here I want to emphasize that here are just some of the examples. So we can have some other VOCs in the air. And the last one is ammonia. So I'm also using another presentation slide. So just a brief introduction. Here is the molecule structure of ammonia. Also, it looks like it is symmetric, but it is polar, which means it can be dissolved in the water. So it can react with water to form NO4 OH-. And it can dissociate into this one. So when ammonia dissolved in the water will become basic. Have you guys ever seen this symbol before? It's usually displayed in the introduction. Do you guys know what's the blue color mean?
Something to do with water, right?
Something with water?
Yeah, like it will dissolve in water. Isn't that it? It's like, and then I thought the red was fire, like flammability.
The yellow?
Yeah, airborne toxicity.
Airborne?
Air toxicity.
Actually, this is correct. So the red one refers to the flammability. The blue one refers to health, like toxicity effect. The yellow one refers to the instability. So it means in the normal temperature, will it explode or something like that. We can see that it has very adverse effect to human beings, and it is a little bit flammable, and it is very stable in the atmosphere or in the normal temperature. And here, So this part refers to like the additional notation. And in this part, it refers to that it is very corrosive. So also, like we have this symbol, it is corrosive, it is toxic, and it is environmental toxic. So this symbol refers to environmental toxicity. And so here are some of the basic properties of ammonia, but I also want to show that when the ammonia released in the atmosphere, like we have this one in the water, and in the water we also have SO4, and we have NO3 minus, and they can react with NO4 plus to form like NH4 to SO4, and this one. But in reality, there may be some of the clusters staying together. So in the water drop, they may have this reaction, and when the water gets evaporated, they become a solid. And when this one becomes larger and larger, they can become PM2.5. So basically, ammonia in the air, it is a precursor of PM2.5. So for this one, do you guys have any questions? No? So briefly about the source. The ammonia source may usually come from the manure, because the manure of the animals, they have the nitrogen. So the nitrogen will be reduced to ammonia and then released in the environment. So for this one, do you guys have any questions? No? So that's it. Because of time, I'm not going to go through this, so you guys can take a look. And so for the homework assignment, I think this is for the organic chemistry, so it will due on this Friday. And again, we have two questions are compulsory, and the last three questions we choose two to finish. And I guess you guys also see the announcement from Maria about the retention time, because we do this experiment for the first time. So it may have some of the new situations. So you guys can just read her email and follow her instructions. And that's it.
Do we have lab next week?
Excuse me?
Do we have lab next week?
Next week. So this week you guys will have the Flint lab too. No, you guys will not have lab next week. So you guys can use that time to prepare for the exam.
The exam is after Thanksgiving, right?
Exam will be the Tuesday before Thanksgiving.
Oh.
So
yes, 360. Yeah, 360.
Yeah, so you guys don't have to prepare exam during Thanksgiving.
Thank you.